Packaged wastewater treatment plants are the perfect solution for communities and resort developments ranging from 10 to 20,000 people. In this example, we will see a virtual installation in a small community. The community has chosen to adopt its own decentralized packaged wastewater treatment plant. Treated effluent from the package plant can be reused for irrigation. Use of this decentralized concept avoids construction of an expensive sewer network. Impact on the surrounding environment is minimized while operational costs are reduced. This packaged wastewater treatment plant has a small physical footprint, resulting in a minimal visual impact on the surrounding environment. This specific example refers to an existing plant serving a community of 225 people with a flow capacity of 45 cubic meters per day. Due to the complete lack of operating noise and unpleasant odors outside a 10-meter radius, the plant can be integrated easily into the community. The plant size is now being shown on the screen, 12 meters by 8 meters. Now let's have a look at the plant's components. The sewage inlet pipe and the flow distribution manhole. The lift station and the corresponding feed pipe. The treatment plant with the corresponding feed pipe and the sludge return pipe to the lift station. The effluent pipe. The bypass line and an effluent sample well. The treatment plant can also be designed for in-ground installations and can operate in climates as low as -55 degrees Celsius. A packaged treatment plant can be contained within a surprisingly small space. Despite its compact size, the unique design features of the plant allow it to treat large volumes of wastewater. Now let's have a look at the processes performed by the plant. When first entering the treatment plant, the influent goes through a pre-aeration phase. The purpose of this first stage is to pre-aerate the flow at a level sufficient to prevent anoxic conditions. In the next stage, sedimentation takes place through a lamella settler. The lamella settler accelerates the settling, accumulation, and thickening of solids at the bottom of the hopper. The first aeration chamber is a hydrolysis and fermentation zone. The microorganisms grow onto the floating media shown in the detailed view. The second aeration chamber is a heterotrophic nitrification-denitrification zone. This chamber and the following ones are equipped with fixed tubular media, as highlighted on the screen. The third aeration chamber performs further nitrification-denitrification with heterotrophic and autotrophic microorganisms. In the fourth and last aeration chamber, autotrophic microorganisms complete the nitrification process. If necessary, the effluent can then be processed through an optional UV disinfection unit. The thickened solids from the primary sedimentation tank can be pumped out to an optional sludge treatment process. This video provides you with an overview of the main components of the treatment plant. Submersible compressor, compressed air distribution pipeline, wastewater feed pipe, bypass line, treated effluent discharge pipe, sludge pumping station, internal walls, lamella settler plate pack, floating media, Fixed tubular media. External structure. Access ladder and servicing bridge with safety railing. Electrical power supply and the control panel. This video describes the flow of wastewater through the package treatment plant. The influent coming from the lift station enters the pre-aeration chamber through the feed pipe highlighted in red. From the pre-aeration chamber, the wastewater enters the primary sedimentation tank, flowing through the passage shown by the arrows. After passing through the lamella settler, the wastewater goes through the bypass into the first aeration chamber. Compressed air is introduced into the aeration chambers through diffusers. The wastewater flows from one aeration chamber to the next through the bottom passages located on the internal walls. The treated effluent then leaves the treatment plant through the exit pipe. The oxygen demand required for the treatment process is supplied by a submersible compressor. Air enters through a silenced pipe. The submersible compressor is installed in the third aeration chamber to reduce noise, keep the treatment plant compact, and keep the compressor running at an acceptable operating temperature. The heat generated by the compressor helps maintain the optimal environment for the microorganisms to flourish, especially in the wintertime. The compressor supplies air through the air distribution line to the diffusers. The second, third, and fourth aeration chambers are equipped with disc diffusers. The first aeration chamber and the pre-aeration chamber are equipped with tubular coarse bubble diffusers. Inside the treatment plant, the sludge formed in the hopper bottom of the primary sedimentation tank flows by gravity to the sludge pumping station. The sludge transfer pipe passes through the pre-aeration chamber and leads to the pumping station, which is located in a dedicated compartment on the bottom of the first aeration chamber. The pump moves the solids back to the lift station. If necessary, the sludge can be sent to an optional dewatering process.